Well. Yeah, that break was way too long. Way too long. Possible values added. I never finished this as a sentence. Oh, actually I did. Possible values added by pipeline 0. So how can I detect that some other thread is going to add for a given index, right? So this is for a given index. Which index? Index. There's an index. I suppose I could add that here. Push back missing. Yeah, so if we do, if have match is false, that's the only problem, right? Okay, so that's inside this for loop and that loops over all these set indexes. So I can look at a single set index. Let's look at the set index that I used before, namely the T4, T3 stuff. Then for the PL0, that would be set index 3. Yeah, it's possible that this whole thing is even empty. So there might be no set layout canonical pointer at all. Sorry. The only thing I have is set layout. So yeah. Suppose I just both they meaning the threads that are running the two pipeline factories. They just both enter this function from the top at the same time. Well, really at the same time. Then both will run over all the shader resources. Plus set index. So both run over all the set indexes. So 0, 1, 2, 3, and then PL0 will run U2, U1, and then T2, T1, and then U3, U4, and then T4, T3. Why is everyone asking this question? So need to make an FAQ. And at the same time, I said, the pipeline 1 is running over 0, 1, 2, 3, and then when it gets here, these two shader resources, and then these two, and these two, and these two, in that order. Yeah, I'm not blaming you. It's just I should make an FAQ because certain questions are asked very often. Next, you want to know what font I'm using and where I get my color scheme from. I bet. I know it's scary. No, seriously. So. They cannot lock this at the same time. Is that not something I can do? Something, yeah, they can actually, because it's a read lock. So they both read lock this. And then this is empty. So they both skip this. Still have a match is false. They both said have match is false and break, even on the first. And I was looking at T4, so let's say, I don't know, pipeline 0 reaches index number 3, tries to read lock T4. Well, why wouldn't it succeed, right? It succeeds, and then it continues running, exits here, have matches set to false. The other one reaches for set index 1, also read locks T4. And then T3, and no, not just T4, and it's empty, so we immediately break here. Both exit this loop and have matches false. So both add this. They push back a layout. Both cases the same handle, because it's the same layout. There's nothing wrong with that either. Well, they might do that twice. Actually, they do that 4 times for each of the set index. And then both add here with the descriptor set layouts vector having 4 elements and the set index is having 4 elements. So they're not empty, and then both want to allocate these descriptors. Well, if I'm gonna stop it, I might as well stop it before it does that, right? How can I stop that from happening? It's nothing to do with Steam, no. It's for a Linux PC. How can I stop this from happening? Hmm. It's one thing you could say is, well, adding means that pipeline 0 is going to add CP11 and CP10, and the other pipeline is going to add the same things to the same shader resources. So if you just look at a single shader resource, let's say this one, then you could think that I could say I could tell the T3 shader resource that I plan to add the CP1 1. So I store in the T3 object that I'm going to add this before I do it. Then the other pipeline, who has the same intention, wants to tell T3 that it's going to add the same thing, and then T3 will say, yeah, well, another thread is already doing that. So at that point you could say, well, then PL1 has to wait. And maybe that will work. What I want to say is, you cannot conclude that that it is not necessary to add it. I think, or is it? Actually, it is. I never want to add it then, in that case. Oh, right. Is this really a per shader resource thing? really. Okay, what the okay, well, I guess the problem is that planning to add it is not really known, not until I find the other one as well. But it's kind of a lock, I guess. I could take a lock on T3 for the time being, where the lock has an ID and the ID is equal to what I want to add. If you get my drift. Yeah, so that means that what exactly am I going to add here? Let's see. The thing that's being added is, well, that the binding is the same, but okay, when do we get here? We get here when new descriptor set is true, which is true when this set index is found in set indexes, where the set index is a translated set index hint of the base. I think that's a match, right? In here I first have the shader resource and then I get the set index, but I'm also doing that up here. Here I have the shader resource and then I get the set index. So the set index that belongs to this shader resource is being stored. No, the shader resource is being stored in shader resources per set index using the set index that belongs to that shader resource. Then later we run over these set indexes and then I get the shader resources again, but they still belong to each other. And there is only one set index per shader resource, so they form a pair. So once we are here, we have a set index and a shader resource, this set index and this shader resource, and they correspond one-on-one. And this boolean is true if we find that set index in set indexes, which is the case when the set index is being added to it, which happens when we do not have a match. set layout. Yeah. Let me do this earlier. Why the hell does this assert not have a comment? I think it holds always. I think it holds always. I think it holds always. So I can copy, let's say, all the 4 lines. Now this block here depends on the descriptor set layouts canonical pointer, which is a function argument, and the set index hint of a shader resource. And that's it. So I can do that everywhere where I have a shader resource. Also all the way up here. All the way up here in principle. Now before I do that, I want to know what is my diff at the moment. I have diffs. Let me commit what I have now. That's too much already. Did I write anything? Any other files that I did not write yet? I think I can just quit. and then re-enter, and then paste what I have. Not writing this, I can commit what I have. Debugging stuff, printing a vector, that was moved. We added a handle there. Yeah, well, whatever. I thought in the end it was needed, I guess, for the working test application. We have an accessor. This was split into functions. Definitely work in progress. Yeah, some more function split stuff. Why did I sort as set layout binding? Cannot remember it. So I sorted that thing for some reason. I think that was not necessary. It's not necessary. I think I thought that was necessary because I was going to apply locks on it and then convert reads to write locks. So yeah, no, I don't want to do that. It's not necessary. Right, sure, let's do a get add minus b. Or can I just, let's do it like this. Stage this hunk. Yeah. Yes. Yes. Which file is this? Is it setLayoutBinding.h? So then I do not need this this operator. I do need a handle that was added, but not this operator. So I can do an edit. I can maybe do a split actually. So yes, split again. It doesn't want to split this. Edit. We do not need this, I think. Yes, for the constructor. Was it just a split? Yes. Only big. Also split, or can I just add everything? I think it would be better if I just highlight it. Set layout bindings. And the current hunk does not mention that, so we should be fine. Yeah, this is just moving local variables to the class and the split of this function. So I can just do yes here. There's a few mentions. So this change back from a set to a vector, then it doesn't make any change. There is no change, this still works for loop. And this is then apparently unrelated, because I don't see the highlight, so I can do yes. And yes for all that, and yes for that. This, however, but it still needs to be locked. Yeah, so that's also a yes. That's a no, maybe? I don't know, where do it's base? Probably not, I'm not too sure. Let's skip it. And leave this hunk undecided. It's a J. Yeah, probably the previous hunk was a no, right? So I don't want to do this. That changes from a vector to a set, so that's a no. And then I get this is making a thread safe, but that would be a yes still. And this I have to edit, because this I still have to lock it, but then we need to push back instead of the insert. And here I have accessories changed into something that returns a CRED. I think that's also a yes. And here we have this undecided set, so I'm going to say no here. That was the only undecided hunk, right? I'm gonna do J. Yep. So I'm gonna do no. Oh, it goes to the next file then. Okay. So this is blah, blah, blah. Yes. And here we have another yes and another const and another const, and that was it. And then I have as div what I want to throw away. Not sure about this. Why is it showing here? Well, I don't know. Good set. Okay. Right. Let me add CWDS in the meantime then. CWDS, git status, git div. Yeah, that does add a possibility to add a set, so I would not need that anymore, but I'm going to add it anyway, of course. Commit -a, add support for printing standard vector and standard set. Git push. Git add CWS, git status. Now we have, I think I can just throw it away, but yeah, I'm gonna just, dash is a bit scary. Well, yeah, stash -k probably. I wrote a Stack Overflow answer on this. I'm too lazy to look it up. I'm just going to not use stash. If you just do git stash, then you put not only this, but also this in the stash. So then I lost everything I just did. Or shall I just look it up? I need to memorize my own Stack Overflow answers. It's a waste of time if I have to look things up. Here's a Stack Overflow. Answers. Yeah. Oh, a few all 100 answers, really? How on earth am I able to find that? Newest. I think this is the most recent one. Now, wouldn't it be nice if I could filter on Git, I guess. I don't know, this doesn't look like, isn't it the reversed order? Not really. Man, I cannot even find back my own answers. How can I find this back? It's only 4 pages. Let's go to page 1 and search for don't know, git. I think this is the one. Yeah, I found it. I think, yeah, okay. So if you already spent an hour doing git add -p, which I just did, do not use plain git stash. Instead, do git stash -k. Okay, I'll do that. So I remember that correctly. It was stash -k. And then I can do a make and see if things still work. Okay, it does. VT. Yep, that works. So then I can do git commit -ma. Instead I'm going to do git commit, and then I'll do whip, and then get back to the uncommitted changes. Git stash pop. Okay, well, really, I don't need it anymore. So instead of git stash pop, I'm going to git stash drop. And then I dumped it. Okay. And then I have something in my editor. So now my git div is empty. And I still have a change here in the editor that I was working on. So what you do is find the corresponding set layout already at this point. That should work, I think. I can write this. File has been changed. Really? The file has been changed. How has the file been changed? It's nonsensical. It has not been changed. Right git. Yes, I'm sure. Git diff. It's the only thing. I think the timestamp changed, but it wasn't changed. Then I can compile this and then run it again, see if this assert fails. Ooh, does not compile. Set index hint is not in. It's not known here. Set index hint. Right. And it doesn't core dump. Still works, of course. Well, it doesn't say much because it's not very exhaustive test, unfortunately. But I do have my canonical pointer now. So I duplicated this code from down here, and then we did get a pointer out of that. The canonical pointer that is being stored is the first argument to whatever this function takes. Set layout binding. Well, that is a set layout pointer, set layout canonical pointer. I'm gonna give it the same name. To be slightly more clear what we're doing here. Now, so I can copy this line as well to up there. I no longer need to assert down there nor the printing because I'm already doing it here. In the end it's going to be removed completely anyway, so let's start with deleting this. And then I'm going to well, now that means that now above there I have this pointer and I have the binding. I just don't have this handle yet, but I could add a null handle, I guess. So let's suppose I add a null handle, then we would be constructing a set layout binding with a null handle. That should work. Just why not? So this means that I can even copy this line and do that here. Can even do that already here. Except I do not have this handle yet, so I'm going to add a VK null handle, I think it is called. Probably doesn't get a color, so I guess that's right. Yeah, but I do not want to add it if it already exists. Is it possible that it already exists? No, I guess it does. It is. Of course it is. So we can attempt to add it. I have no idea what I'm doing, really. Well, maybe I am, but I don't have an overview. No overview whatsoever. What am I doing? I'm adding set layout binding that I might add. I might add it. One of the reasons that I would not add it is when one of the reasons I will not add it is when it already exists. That's one reason. Another reason would be when eventually here I'm going to say I have a match. But if I have a match, doesn't that mean that it already existed? Can I have a match here without that it exists already? That's a good question. Well, if this is true, then this was never called. Then still have match is always true, including for this canonical pointer. Means that we do find it. We find it. Well, we would already have found it if I hadn't added it. So it did already exist, and the binding corresponds. So that means that it already existed. Kind of like that. The only reason I would not add it is when it already exists. That's silly, of course. There's another reason I don't want to add it. if one of the other necessary... No, that's not true. If it does not exist, I always want to add it. Yeah. If it exists, I never want to add it, and when it does not exist, I always want to add it. That's really weird. Is that really, really, really true? Seems to be true. It's amazing, but it seems to be true. So let's... And then I have to change my vector into a map. Really? Yeah, I think I have to. Okay, so that sucks, but... Or I can change it into... I can change it back into a set. Yes, and I did throw away my div. Yeah, well, it wasn't much. Okay, this has to be a set anyway, then. Change it back. This becomes an insert because it was a set. It had to be a set. Had to be a set after all. What all did I change here? Set layout bindings container. Here, this was a set. I think that was the only thing apart from the operator less than. Yeah. So we need an operator less than on this set layout binding. Let's add that back. Boolean operator less than. Friend, just going to make it a free function. Standard layout binding. Cont reference left hand side. Right hand side. Yeah, and then I had so order it on this first. Right hand side. Return true. And then if they are equal, and binding is a less than binding, return true, otherwise we return false. I think that's what it was. And yeah, we're ignoring the handle, so it doesn't really matter that the handle is a null handle. And we can just insert a thing. But the insert is returning something, which I now need. Auto result equals that. I'm going to make this a boolean, and now we return I think it's second. Standard set insert. Google. Standard set insert returns standard pair iterator bool. So the second bool is true if the insert happened. So existed is not inserted. Yeah, well, what now? What now? I think it would be fun to see that I do not even have to call add set layout binding anymore, because it's just inserted here whenever that's needed. I just need to set the handle, so I'm going to add a new function to the shader resource that writes the handle. And then we use that here, which means I do no longer, well, yes I do. I need a key. So this is the set layout canonical pointer then. And we have the binding. I still need to almost pass everything. Nah. I'm just going to do set layout binding handle. And then we just pass all the parameters separate. So this becomes store pointer. No, not really. Store the handle. What is it? Descriptor set handle. Store descriptor set handle. Corresponding to this pointer to the canonical copy of the US set layout along let's see, just canonical set layout and binding number dot 1. Now, didn't you wish that you could pass that set layout canonical pointer from above to here? because we already did this find and everything. Isn't there an easy way to pass that? I guess I could store that also in a vector along with this, or even the set indexes. Because we did find it, so it does exist. Might as well find it in the set indexes then. Or maybe stored in the set indexes itself along with. But it do not really have the index of this thing. Well, yeah, that would make things slightly more complicated. My problem here is that I do not like code duplication, and this is code duplication. This whole line, these lines, both, I just copied them. No, I cannot store it in the set indexes. It's a per shader resource thing. Let's leave it like this for now. Okay, still have to write this function then. Set layout bindings handle. So something, and this can be a void, and it takes some I guess it's equally thread safe const. And yeah, let's jump back. In the end I need a key anyway. I can find it by key. So I'm not going to do this. I'm just going to what I really want is a replace, isn't it? So this is add set layout binding. I'm just going to replace. And then I don't have to pass the handle. The reason being that now I do pass the handle. So now it's called like this. And I'm just constructing this thing in the same way. Except now we do not pass a null handle, but we pass the real handle. So I'm going to say no handle here. Okay, this is with handle, but it already exists. So what I want is to replace. I want it to exist, and I want to replace it. Don't think that set can do that with an existing something. So existing something, and then just put it in. And then even tell us that that succeeded. I don't think that works. Let's try to look it up. What would you have set? This is insert. Okay, 1 and 2 inserts value. Right here. If the container doesn't already contain an element. So none of this insert will work. And place a hint is the same. Sub extract merge. Can't find contains equal range compare. Nope. No, it's not possible. We just have to find it, I think. Find. Is there a find here? There's a find here. Find by key. Well, this is a set, so everything is a key. Can do iterator find the thing. And it must exist. That returns end if it does not exist, so it must be unequal end. And we need a comment because it is an assert, and the comment is this key that is the part of the set layout binding that we compare, and that is the pointer plus binding. It should already have been inserted with that. So if we do not find it, then we did not call the add set layout binding with the right thing. That would be the error. And if we do find it, then well, I don't think that this iterator can be changed. What kind of iterator do we get back? We get an iterator back. If our thing is non-const, well, it should be non-const because I have write access to it. So I get an iterator back to I don't think there's even a difference. I don't understand this. How can we ever get a writable iterator that said that wouldn't work? I mean, normally set uses the whole thing as a key. So if you change that, then you would have to reorder it. Therefore, the key is const. So why on earth would they return an iterator? instead of const iterator. But it could be that the iterator dereferences to a const key again, and then we cannot change the const. But then you wonder why they have two of those functions. Iterator, yeah, iterator. There's a constant legacy bidirectional iterator to value type. Okay, it beats me. I'll just let the compiler take care of it. I don't think, well, we're just going to change it, and I think it won't compile at first try. So ID reference is this key thing, and then I'm going to change the handle. Handle becomes the handle of what we got passed here. Except that that won't work because it's a private thing. So I need to have a explicit set handle thing here. I can get the handle. Also need a set handle. You set the handle later. Hell, I don't even need to pass a handle here, because when I construct these things, I never have a handle, right? Currently. Let's not set handle. Handle. Cannot type handle. This handle is gone. And I'm just always constructing this thing with the VK null handle. And I'm adding a function set handle. Handle now, because it sets the handle, it's not a const thing, right? And I think therefore it won't compile. But let's just test it. So this sets the handle, handle equals handle. And the reason that it's allowed to change the handle is because it's not part of our key. We do not use it in the operator less than. So changing it does not change the ordering of the set, and therefore it's okay. And I do want to add an assert here that the handle may not be set before. Only call this function once. Period. And this is construct a set layout binding without a handle. That is set later with set handle. Great. I think that should work. Oh no, not really. Control T. So now I call here set handle, and we pass the accessor that we have already. That was called handle, right? Not get handle. I don't know. I'll never know because handle appears a billion times. Do I give up already? I think I give up. I'll just see. If it doesn't compile, then it was get handle. So now we can see it. Set handle and handle. Okay. and now this is not compiling, I think, because it's just const. The iterator is returning something that is const. Yeah. Well, I don't know. I just don't understand why they have a set defined like that. But yes, so because it might be part of the key, the iterator is returning something that is const. So we want to call set handle on that. It has to be const. And now we cannot change handle anymore unless we make that mutable. It's kind of like my thread save const trick, but in this case we are not using this as part of the key trick. So added, yeah, not used as part of the ordering key. It's not really a key, but it's kind of like using a set as if it is a map without using a map. It's also in one of those books by what's his name. Now, of course, it still doesn't compile. And it really goes on not compiling for a long time. And that is because I changed the constructor. Oh, I cannot do this anymore. Stupid. Okay, that was stupid. Definitely stupid. Yeah. Well, then I have to add a constructor back. But I do not. Do I want to pass null handle here, this explicitly? Maybe I do. It's kind of more clear, to be honest. I could just remove it here and then change constructor, etc., like I did. But what am I gaining with it, right? Nothing. Okay, we have it back. Add it back here as well. Yeah, with the handle, no, without the handle. But not really anymore. I'm doing it both. Okay. So handle might be vk null handle. In which case it is set later with set handle. M handle. Okay. Try again. It compiles. Okay, then of course I don't know what anymore what I was doing. I think it should still work. It doesn't. Annoying. Right. What did I do wrong? Okay, this is rather painful because I have no clue. So let's look at diff. I made the handle mutable. Then there's a set handle to change it afterwards. And we added back the less than operator to sort it. So we can use it in a set. And now very early, I'm finding this thing here and adding it, but with a null handle. Yeah, that's probably the problem. Definitely the problem. Assert, this is moved now to the top because it was already inserted. So now the only thing I have to do is, oh no, this is just assert and the art, and this is nothing actually. And this is replaced with that. No, basically no change here. Well, except that we expect it to already exist with a null handle here. That seems correct. So change back to a set. This is used with a null handle. Right. So yeah, the only thing that can be wrong is that now I am adding it here, which means that which means that it exists and we're going to run over it. Yeah, I take the write log and add it. Then here I take the read log and run over it. So what we just added, we always find here. And this is going to be set to that thing at least once. And the binding is also correct, always. So this is always going to be found. And we always have a match. Nevertheless, I don't understand the validation error that I did get. Oh, and then and then it sets existing descriptor set to 0. Yeah, to the null handle, because I just added the null handle. Right, so I think that what we should do here is ignore what I just added. That seems the most logical thing. So let's say if the set layout binding handle does not exist or is still null handle, then ignore it. Okay, continue. Being not. I think that this fixes the fact that it stopped working. Two, three, 1, 2, 3, 4. What? Still doesn't work. Assertion failed. Okay. Maybe the assertion is wrong. VI, clip, boing, assert ether is unequal and. Oh, no, that's weird. Totally weird. So it could not find my key. No, I don't like this at all. How late is it? Not late. Why? Why can't it just work? This is way too complex to debug. I don't like it. It should work without debugging. I must be overlooking something, but could it be that the assert is wrong? And we try to insert something that did not exist, does not exist. Okay, let's print the shit out of it. Loads and loads of debug output ahead, which means that I should commit first. Diff. Okay, I still stand behind this mutable and the set handle and everything. I think it's generally a good idea. So maybe, no, that would not lead to that assert. Oh wait, I think I understand it. It's a race condition. We're having two pipelines and one of them is adding it and then the other one is also adding it. No, wait. No, I'm saying it must exist, so that wouldn't be the case. Using certain point context. Okay. Wait a minute. No, nonsense. Okay, I think I can commit this. Yeah, so I wanted to add a loads of debug output. Oh, that's not nice of it. loads and loads of debug output. And it is printing when we add handle shader resource creation requests, and then after that it's going to enter this, and it's printing that it enters that with owning window, inside binding map, and descriptor set layouts canonical pointer. Might be interesting to see what that actually contains. So I have a vk utils print pointer. And this is a vector, so that should work. But it's a vector of set layouts. All those things are so huge, and I print all of them on one line. I need to start inserting new lines, I think, or some kind of formatting. Otherwise the debug output is no longer readable. Yeah, I need a debug name for the shader resources, so I understand what we are talking about. And what am I doing? Base. The base has an ambifix. This is base. What kind of nonsense is this? Implementation of virtual function of base in base, and it's not even virtual. Huh? What? I think it's no longer a virtual function. I moved it at some point. So yeah, I can call ambifix, and now we have a debug name. I think the ambifix is even printable, or isn't it? I think it's not printable. Maybe I should make it printable. But okay, just call object name on it. And unfortunately the thing is protected. Why would I want it to be protected? Because it's only called from derived classes. Yeah, not anymore. No, nonsensical. Who cares? Let's make it public. Let's repeat this inside a debug thing. Okay, so now I have a public ambifix. Let me think. Base is base class of a, yeah, this is not thread safe. Maybe that's why it was protected. Well, it's again thread safe because it's const and because of the order in which we write things. Okay, it's only written once, and it would be kind of stupid if we read it even with a single thread before we initialize it. So you can assume that the right one's thing has been written to, and then only then threads will run that read it, and they are allowed to read it at the same time. So I guess it's okay. And we're going to read it at the same time by 2 different threads. That is okay-ish. You know, officially it's not okay. It would not be okay if there is not a synchronization in between it, but there must be a synchronization point in between it, like unlocking a mutex. That kind of guarantees that, say, whatever this function did by some thread will be visible to all other threads once they call this, because they have been synchronized using a mutex. Now the mutex is nowhere inside here, but it just has to be the case. Otherwise something else would be wrong. So it's really difficult to understand this stuff, but yeah, I think it is officially okay. Anyway, in practice it works, and it is debug code, so who cares? Well, I could add what I'm adding to this vector. I have to print like everything that happens. Do I not? Yeah, let's just do that. Shitty work, but I'm gonna use notice because it's hell. I'm gonna use debug. Running over all. Now the key is not really interesting, but I want to see the set index even. Setting this hint, I mean. A set index hint, well, setting this hint. Set index. Let's add an equals sign here. Set index. And that is enough information, I think, because I'm just storing that information now. Okay, so this is an important loop. I give it a name. The RDC notice entering loop X. Now it has a name. Can even make it an entering here. Now we get an indentation as well, but I want to make that indentation go away when we reach the end of the loop here. So then I have to add a scope around it. Yeah, I guess same thing here. Now I have to print what the set index is here. What am I doing here? Set index is set index. No. Right, yeah, let's add a loop here as well. Okay, I think I did that wrong up here. I'm going to see if it compiles at this point. What tag? Function definition is not allowed here. Yeah, right. No, that doesn't make any sense whatsoever. This for loop ends here. Yeah, then I need that. I have another one here. I had one missing brace. Still columns at the same place. Yeah. I don't like this output. It's not interesting. I don't know. There's quite a lot to print. Because this is too verbose. Let's just keep printing this. Oh, I just printed it. Let's just not print it at all. Okay, let's see. Add layout binding. Add set layout binding. Probably have to print it. So I think that every time I compile, my computer uses like 300 watts or something. And it takes a minute to compile. So that is 60th of an hour. So it's 0.3 divided by 60 is 0.005 kilowatt hour. So if the price is now 4 times higher. Let's say if the price goes up to €1 per kilowatt hour, every time I compile, I have to pay 0.5 cent. Okay, can't live with that. It's probably more expensive to just keep my PC running all day. But I was just wondering. Error. No. Use of undeclared identifier. Fix that. Make. It compiles. Aha. Yeah. Okay. So I have debug output. Still crashes in the same spot. Do I already have debug output enough is the question. Probably not. Let's keep adding debug output. Yeah, still have registered true. It's kind of strange that the set index itself is not set here. Oh, set index is loop variable. Okay. Let's add the set index here anyway. I do have it. Set index is set index, and then binding is binding. Right. Well, that's a lot of debug output. Maybe we should have a look at it. I don't know what else to add right now. Okay, so I run this. Now I crash on not found. Let's write that to a file. Let's print it. And then the question is, what the hell happened? Do I still have viewers? Because if I don't, then I'm going to change. Oh, I have lots of viewers. Lots of viewers. I don't know why I'm lots of viewers, but I would like to make my font a little bit smaller so I can see more at the same time. But okay, this is thread pool number 3, and it must have entered my function at some point. Create object. Set state, create shader resources. Oh, here we are. Okay, apparently the threads are not running in parallel at all. Oh, there's thread pool 1, but it's doing something totally different. And I'm going to assume, or maybe I should check that. Is this a second thread that enters this function, or is it the first thread? So we should have a look. I search for this, I think. It's the first bloody time we enter it. Well, it actually makes things simpler, so I cannot answer questions that are, I don't know, distracting me from the real thing, say, like what is vulkan and what are you making? And I'll input data. A bot 7. Yes, I think it's a loop. Yeah, well, it's funny. No, I'm just an AI that experimented, tests how long I can fool people on YouTube thinking I'm a coder. Shader input data. There's only one called once. Okay, we have not the identity. Set conversion. It's calling a log which succeeds on 4 things. Probably have to go faster through this, right? Fast. Okay, so we begin with this is handle shader resource creation. So the only thing it's going to do is create things, especially because we are the first thread to enter this. It creates a uniform buffer base. That's one uniform thing, and then the second one third one. Do we not get to see the creation of the texture? Probably not, because that is a no-op. Entering shader input data, allocate and update missing descriptor sets. Okay, that's the second part of the function. And this one is going to crash. So we do not leave this function until we already crashed. Let me check that. We go down. Not found. Okay, and that is all that we have to read. That's like 3 pages. Entering, allocate and update missing descriptor sets. The set binding map is not identity. I'm being passed a pointer to something that has sorted bindings. Binding 0. It's a uniform buffer. And we have one with this bindings that's also a uniform buffer. It should be the same handle, I guess. Yes, it is the same handle. And then we have one that has a binding 1 for a combined image sampler. And another uniform buffer, and that's a different handle. Okay. Entering shader input data, get VHV descriptor set layouts. No, so the descriptors printed again. Running over all, this is debug, so we are back in this function. Running over all M required shader resources list. Shader resources, yeah. Shader resource sample texture. So do you have 4 shader resources, a texture and 3 uniform buffers. This one has a set index hint of 1. And that should be the same on the top, and it is. Set index is 0. Okay. The set index also here 0, of course. Set index is 2. So that's after the conversion. Entering X loop over set index 0 to 2. Set index is 0. That means that we're going to get the sample texture in the top buffer. Entering loop over all shader resources. Shader resource is the sample texture. Binding is 1. Well, I think I saw that up here. Binding is 1 for the combined image sampler. That looks correct. Of course it's correct, but because nothing is happening. Just entering this thing. Created object shader input data dot shader modules. So that's a different different thread. Thread pool 3. Shader resource corresponds with set layout canonical pointer. This is a sample texture, and it says that corresponds with set layout binding 1, and binding 0 is a uniform buffer. Yeah, well, that looks totally correct, right? I mean, it's the only one that has a texture. Entering add set layout binding. Set layout canonical pointer. Sorted binding, this is the thing that we just had. Binding 0, set index, blah 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 blah. And binding 1. Well, okay. It's not mentioning the handle, but that is null. Entering add set layout binding. Yep. It did not already exist. Well, I'm happy because this is the first thread that enters this function. Setting have match to false because still have match is false. I think I found a bug. I expected everything to be added afterwards, right? And it's only adding the texture and not adding the top buffer. So it's early bailing out. I must have a short circuit in my brain because I really thought that it would not do that. Let's have a look at the code again. CD source vulkan pipeline. Here's the X loop, and now you run over all the bases. Oh yeah, so this break here breaks early out of running over all the bases, which means we're not adding them. What happens if I remove this break, and is that something I want to do, or? Okay, anyway, that's a good reason that we are not calling add set layout binding for all the shader resources. So they do not always exist afterwards. Yeah, what might result here then is that if I do not add it, that another thread tries to add it, and that would succeed. So then one thread added one of them and the other thread added the other one, unless I make sure I try to add them always in the same order. Ouch, yeah. That would be nice. Otherwise, I have to add all of them, but even then, I think the break is okay, but I really have to make sure that I add them in the same order. Add them in the same order, meaning what? Meaning the shader resource. Yeah. And the shader resource is a base pointer in a set. If another one does the same thing, it must definitely run over the same ones here. I think that the shader resources per set index must be sorted. So if I sort this thing, yeah, I remember that I said before that the order was undefined, but it must be ordered. Okay, I'm going to sort it. So here I have a push back. I'm just going to sort it afterwards, I guess. Standard sort. Begin, comma, int. Yeah, that was int, like that. Okay, so sort this vector so that pipeline factories that attempt to create the same descriptor set will process the what is the word? Cannot find a word. The dot shader resources in the same order. I guess associated. I would do. I'm going to scroll through the chat because I'm really interested to see if this spam bot is killed automatically. Too many symbols. Oh my god. Well, it did delete it. Did delete the spam bots. Doesn't say why. Well, that was that one thing. Yeah, too many symbols. Unbelievable. Maybe I can add a better filter for it. But it seems to work. Awesome. Okay, so now this is sorted. We kind of can assume that the break will work because every thread is going to try to process the shader resources in the same order. And then if I add the first one, the next thread is going to encounter that also. I meant, where am I adding it? Here. So the first one is going to add this, and then the second thread is also going to consider this one as the first shader resource, finding that it was already blocked. Which is necessary anyway, because otherwise two different threads might block different shader resources. So definitely going to deadlock. Okay. The immediate result of my break here is that in the second loop it is possible that I call replace set layout binding while really it doesn't even exist yet. So maybe I should rename this thing. I could rename it to, well, replace is okay. It's add or replace in this case. Now I want to call this one add. I don't know why. It's kind of the final add. It was here in the first place. It was called add. And then if as a side effect it might do a replace, who cares? So I'm going to rename add to something else and then rename this one back to add. Remove this highlight. Yeah. I wish I had ice cream. I always crave certain things most when the shops are closed and I know for sure that I cannot go buy it. The occasional time that it happens that I crave something while the shop is open, I think, I would think something like, I would like to have an ice cream. I could get up now and go to wherever they sell it and buy me an ice cream. But I'm coding. I'll do it in 10 minutes or in an hour or in half an hour. And then I don't do it. Until the shops are closed. And then I think I would like to have an ice cream. I'm like, it's impossible to get an ice cream now. But the shops are closed. I so much want to have it. Feelings get much stronger because of the shops. This is why all shops should be open 24 hours a day. QED. What was I going to do here? I wanted to rename this function into pretty much null handle. Yeah. So block reserve, or I'm still doing preparatory work for fixing the race condition in the first place, and so far I haven't done that. I'm just splitting functions and God knows what, all in the hopes that it will help me to fix the race. And I added this because I think it's going to help with some kind of pseudo lock. So I might rename it again, but let's say I'm already going ahead and calling it lock. Even though that's totally not what it is at the moment. Add multiple things in here, so I'm going to call it just add comes lock That was all. Then there's only one left. Drag all lock, and then I can do the replace thing. I'm going to replace this one with add then. Yeah, okay, rename. Do it like that. There's only one here in the whole file. Pretty sure about that. So this becomes again add. And then oh, come on, the bot is not doing its work. Well, it does, but very, 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 very slowly. Yeah, Matthias is totally right. This is not pre-recorded. Might as well be pre-recorded because I hardly read it yet. But occasionally, let me see this thing. 1, 2, 3, 4, 5, 6 symbols, or six smileys, emotes. I think there was too many symbols. Okay, so TPS add set layout binding. Something is horribly wrong. I renamed this one, but I did not rename the other one. Okay, so I have to look for replace, I think, then set layout binding. And that's then renamed to add. And now it is an add. I do not need this anymore. And as we do a find, the assert is gone. And then it depends. If it is end, we have to add it. Otherwise, I have to replace it. So now I just do the same thing as above here. Insert. Pretty sure that would be correct. Yeah, well, Harin Kut UK. I'm Dutch. Do you live in the UK? Just asking. It compiled. What do you think about that? UBT. It works again. It works again. I didn't fix anything. I just broke it and then I fixed that. But in the end, you know, I don't know, it crashes. Oh, fuck. Fuck me. Thought it worked. Well, maybe this is to be suspected actually, because I'm doing some weird things. If this was a real bug, I would feel like screaming. My only hope is that if I fix this locking thing, that this will go away again. Because it worked, right? I had it working. Ran it several times and this never happened. And now suddenly I get this. Okay, so maybe I should look at the debug output with this, but I might have scrolled off my... I didn't write it to a file. Yeah, I'm going to attempt to debug this with the scroll back. I want to even have colors. How beautiful is that? So its problem is that descriptor set 0 being bound is not compatible with overlapping descriptor set at index 0 of M pipeline layouts due to descriptor set layouts. And then we print a key. Binding is 0, descriptor uniform buffer, descriptor set 1 says vertex minimal, and that's also just a single uniform buffer thing. From the pipeline layout has 1 total descriptors. Yes, that's the uniform buffer. But the descriptor set layout binding 1 with a combined image sampler and also a uniform buffer, blah 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 blah, which is bound, has 2 total descriptors. So there's a mismatch between in the function, the layout, in the function vk command bind descriptor sets. Okay, and let's find the handle of. It would be nice if I knew which one was correct. Probably. Yeah, the pipeline layout is correct. Like by definition. From pipeline layout is 1 total descriptor. So I should not pass descriptor set handle to index 0 that has the texture. And the pipeline is 2. Pipeline layout, object handle, da da da. So this is my pipeline layout. Descriptor set layout. No, I wanted to highlight this. What the hell? Okay, now my mouse doesn't want to paste anymore. Okay, give up. Let's try to reproduce it and write it to a file. Oh no, it's like broken like that again. We're set back, we're set a month back, as it were. Forget it. Get it. I think I just never fixed it. I don't know why it worked at some point, but I was surprised, I have to admit. I was like, huh, what? Oh, well, that's nice. I don't know why, but it works. But now it's broken in the same way as before, so it was never fixed. Which makes sense in the sense that I originally didn't think it was fixed. I was just working on molding the code in a way that it would allow me to fix it. And now we've been taking, working on another part, and the code has been changed again, and now the race condition is back. So we just get serviced the same bug serviced again. I think that's what's going on. And I think that what I should do is first fix finish the locking here that I'm working on now. And ignoring that we have these crashes and all what not. Okay, so I introduced something called lock. The idea of this was that if a thread tries to add this early, like in this loop now, and it sees that it already exists, then that can mean two things. Either it actually exists, and we will continue to use it here because the handle is non-zero, which then means that the binding will also be equal, like because, well, we found it, so might as well test here on existed instead of on binding, as it were. So we still have a match. So if we find it, we found it. That means that yeah, we still have a match, right? Until we don't, and that means that we jump to the top here of this for loop, run over all the set layout bindings, and no, that's not true. This is just simply set to true. I'm looping here. Why am I not breaking out of it? Well, because I want to increment the admin here. I need to do all the increments. So we are not going to break out of this loop because we found it. And then we go to the next shader resource. And if we find all of them, then yay. But the second option is that it exists, but the handle is zero. In that case, it is being ignored here, and we're going to break out of the loop. But in that case, it means that some other thread has this thing added and not filled in yet. Now, getting a headache a little here. I think what it means is that we have to back out here if existed is true and the handle is null. Then we must back off. We could leave the function. But then when do we start running again? What if I add a task mutex to the set layout canonical pointer? It's going to be the same for every shader resource that is involved. No, not. I'm just going to have to wait. We're going to have to wait for a signal. The signal is related to the object that we find. We are waiting for something. Shader resource. So difficult. I'm starting to have the feeling that I must be doing something wrong. Nothing can be needed to be this difficult. I think I'm really just too stupid to do this. With the 100% clear full overview and analysis of the problem, that it should be possible to write simpler code. In my opinion. Yeah. Yeah, I don't know, man. I feel stupid a lot lately. When I was 18, I did stuff that I do not even dare to tell you. Because then you think I'm too arrogant or something like that. Then I was smart. But now, nah. Also, this point here takes a write log to add something, and then here I take the read log. I'm thinking about if it doesn't help, wouldn't help. I'm 58. I'm really old, man. It's been at least a decade or more that I start that I'm not able to find the words anymore. Or want to say something and I cannot think of a word. And well, at that level, I should not be able to code anymore. The only reason I can still code is because I do it every day, many hours. At some point I stopped for 1 year, and then after that 1 year, I already had the feeling that I could not code anymore. It was like all gone. But because I persisted, it came back. But yeah, it's got to be degrading one way or another. Yeah, I'm not that tall. I think I sound like anyone would sound with the size of my chest, something like that. It's the chest cavity that determines how you sound. So I'm not really sure what you mean, because at 30 people already have stopped growing. Why? I don't think the voice changes of people after a certain age. Voice is really, really long time exactly the same. When you start to talk really old, you're almost dead, if you ask me. I mean, maybe even my dad's still 80, 86 or something, and he still talks like he sounds the same. He's going to be 100. His mother was 102, I think, when she died. Auto, yeah, auto is kind of like a template thing. It's a type that figures out the type by itself. Say if you would pass, there's an auto here. If I would pass this to a function, to a template function, that took a template parameter t, then it would figure out what the type was. The type would just simply be whatever this function returns. So it can also do that if you assign it to a new variable. So So this auto is just going to figure out what the type is, and it's just going to be the type that this thing returns. Now that's my dad. My mother is also 86, and she's almost dead. I mean, she cannot walk anymore, and it's literally breaking down. Everything. But I always thought I would become 80 and then die. That's most of my life. I assumed that. So anything I get after that is well, extra. But I'm afraid I will, at some point, there will come a point in my life that I will just have to admit that I cannot program anymore. My dad has been a system programmer for Philips. So he has been a programmer for most of his life, and he was also programming as a hobby on the PC. And he has stopped pretty early too. Not recently, decades ago, I think. So of course he went to pension at 65, and well, at that age he was already not really worth anything as a programmer where he worked. I think at some point he changed from being really a programmer to something else, like data analyst or something like that. Something more suited for a senior. But I've always been surprised that he also stopped writing programs on his PC. Now maybe he did that, when he was 70. So I still have 10 years to go. So the level at which I try to program is pretty high. So it might be sooner. It might be that in 5 years I will already have to admit that it's not working anymore. Anyway, yeah, so what I have in my head is multiple threads run this function. The first thread that gets here and that might collide with the action that it is taking and an action that another thread is taking, which means adding some objects. No, actually it means creating a descriptor set. And then in order for the other pipeline factory to know that it is doing that, it has to add certain data to every shader resource involved. And it will start with adding that to one shader resource, but since I do it in order, I order the shader resources, this first thread is going to call this function, and then that is that is the point at which, now I cannot find a word, for example. Critical point, decisive point, canonical point, just the point at which it is decided that that thread is the one that is going to create whatever race there might exist. We don't even know if the races yet exist. And the main problem is here that I lack my overview. So I do not know if this, how it's all fuzzy. I mean, is it even going to work at all if I do it like this? I have the fake feeling that I think that the model in my head is now that if there is a problem, it's going to be a problem with every shader resource of the whole set that is a part of that descriptor set. Yeah, that seems very, very logical. I think that's true. So also with the first then, and then the first time we log this, we know that the other thread will notice that. So the first one that logs it gets an existed back that says it didn't exist, and the second one then will return that it does exist. But then what to do with it? So if existed, and it doesn't even really. I'm not even really interested in if it existed. I'm interested in if it is in progress. So maybe I should rename this to in progress. And then we cannot continue if another thread is in progress with adding this descriptor set. And in progress then means that not only did it exist, but also the handle that we found is null. So this returns a pair of an iterator and a boolean, and if it existed, the boolean is going to be true. And then the first is the iterator that points to the already existing element, and if that iterator is dereferenced, we get the set layout binding, and then you can call the accessor handle to get the handle, and if that is that is false, was a VK null handle, that then means that it is in progress. So that is like if some thread is adding this, is calling this, it adds a VK null handle. The second thread then will see that it exists and that it is a null handle, and that means that it is in progress. That was the reason I moved this code up here in the first place. But then I have to back off. And how can I do that? How can I back off here? Until the point that, until the point that that other thread continued running and called this function. After it called this, we may continue. Well, not really, because there are multiple shader resources involved. So it could do this for the first shader resource. Maybe it should just process the shader resources in reverse here. That's an idea. That's a very good idea. Yeah, if I run over this list in reverse, I'm actually using the same trick as we did before. Well, not really. The same as I did here with unlocking reverse order. Is it always going to be the first one that I lock? So the first one, okay. Let's have a new ASCII adventure, ASCII art adventure. So all these test things are too small. I need something that's way bigger to really test it. But okay, right now, let's say we have a descriptor set that involves many shader resources, and the descriptor set involves well, let's call it R of resource, resource 1, resource 2, resource 3, resource 4, whatever. and we always process them in this order. And the first thread will begin with calling lock set layout binding on R1. So it adds something. It adds something to this shader resource that with a null handle. And I don't care if it continues or not, because the other pipeline factory will also either try to look for something completely different, and then I really don't care. They can process this in parallel and both create their own descriptor set, new descriptor set, because it's a new descriptor set anyway. So the only problem is, the only race exists when the other pipeline factory also wants to process R1, R2, R3, R4 with the same bindings and everything. Everything must be the same. So also the resources that are involved. And they are guaranteed to be in the same order, so the other one will also first try to lock R1. But then it will see that it is already locked. That is, that already this has been added with a null handle. So it stops here, and it's not going to process R2, R3, and R4, which means that the other one that was first at its leisure can add a null handle here, and a null handle here, and a null handle here, and then figure out that it must add it, and it will add it, and then it comes all the way here, and then one by one it is going to do I have to think about something else only? Yeah, okay. That's exactly not true then. This one was first in the sense that it added a null handle, which means that it did not exist, which means that it immediately figured out that there is no, okay, we have, sorry, now I'm suddenly seeing the light a little bit better. So we have a set with a lot of resources. The end state is when all the resources have a handle. I'm gonna use ++, so this one has a handle, this one has a handle, this one has a handle, and this one has a handle. That's what we want to end up with. If this is the state, so the really completely finished state, and there is a thread coming here which calls this, then that is going to return false because it's not in progress. And the handle is not null, the handle is set. That means that it will, because it exists, but it's not in progress. So the progress is false, but we just continue running here. And because it exists, it's going to appear in this list here. And the handle is not going to be null. So we continue here. And then there is still a possibility that the binding number does not match, but that is a separate problem, orthogonal to it, maybe even more or less, at least at the moment. So we can assume this always to be true. And then we will always increment the counter for layout for every shader resource, which then keeps up with the shader resources. So we're always going to say we have a match which means that this is always true, which means that we never break, which means that we run over all the shader resources. So it's going to check this one, in progress is full, then it checks this one, in progress is false, then it checks this one, in progress is false, then it checks this one, in progress is false. And every time still have matches true, which means that we have matches never set to false. So when we get to the end and we checked all 4 of them, we come here and have match is true, which means that it is not added to missing descriptor set layouts, and we are not going to create a new descriptor set out because it already existed. Now, another state is the state where nothing was added yet at all. So these are the resources, but nothing was added. Then the first one that encounters this says, okay, R1 does not have a handle. Yeah, it does not have a handle. We do not encounter this. And then it just stops. It knows that if this one doesn't have a handle, then we do not have a complete set with 4 handles. You do not have to check if the other ones have a handle. So here we encounter a break. And it adds a null. Okay, it adds a null handle. Let's switch from the minus to 0, 0 here. It adds a null handle and it breaks out of the loop because it wants to create it. And then another pipeline factory that comes here gets returned that it is in progress, because it's also going to check R1. It does not see ++. It sees null null, which means that it is going to return that it is in progress. And it is going to halt here. So this means that it's halting. Now what is this thing going to do? This thing, it's not bothered by any other thread because all the other threads are stopping. This one has broken out of this loop here. With this break here. So we left this loop. Be not be confused with braces in the first column. They are just debugging braces. So this brace is not here. So we left this for loop, and then we do have match. No, we do not have a match. We did break after setting have match is false. So now it is immediately adding the fact that this set index needs a new descriptor set, and well, with this layout. We'll also store at another vector at the same index which set index that is, and then we allocate that thing from the missing sets layouts, allocate a new descriptor set, and then we run over all the base resources, and this time we're going to run over all of them. And then if I find the corresponding set index in this list, set indexes, then I know that it just was created here, allocated. So then we are here, and then we update it because that's what we want, what we need to do with every new descriptor set that was created. Update the descriptor set, and then finally we are adding the handle that we now have, we just created to it, and then that means now it turned into a ++. So if we do that in this order, starting with R1, then what would it be? Then what would happen is that this 0, 0 is now changing into a ++. At that moment, another thread could come in or even be started again. This thread, for example, maybe it would be started again because we added a ++ here. Doesn't know about anything about the others. And then I would check it and would say, yes, we exist. So in progress is false. And for the first shader resource still have a match is true, have a match is not set to false, and we go to the next shader resource with the same set index. So we're going. Yeah, I'm assuming that all these shader resources R1, 2, 4 have the same set index. So it goes to R2. Sorry, here. And then if this thing did not, oh wait, it did not add a 0, 0 here. And it also did not add a plus plus yet. I could have, but maybe not. So then this thing here is going to add 0, 0. Oops, that's not good. Therefore, I think that the right thing to do is to run backwards. So I leave the 0, 0 here, and I'm starting at the end, and I'm adding plus plus here, and then we're adding plus plus here. And all this time this thread is hanging here. It's waiting for R1 to be have no null handle anymore. Any new thread that comes in, same thing. It just sees the null null still and it would hang. And the thread that added the null null first fixes all the other resources and then finally fixes that one null. And now we have this state, and we can simply say to all the others that are still waiting, okay, you can continue again. And then it will find that it exists, all 4 of them. And it will reuse the descriptor set. So that's what we have to do. We must begin at the end in this loop. So the comment here is going to be run over all shader resources in reverse, so that the first one that has a VK null handle added is processed last. Okay, let's run in reverse over this. How do we do that? I don't think you can do that with a colon operator easily. Well, there seems to be a standard ranges reverse, but I could not get it working. Tried that a few days ago, very shortly. So I'm going to run over, let's use an iterator. It's going to be a shader resource iterator. Reverse begin, iter is unequal, reverse end, plus shader resource iter. That's one way to run over it reversed, and then I'm just going to assign it by dereferencing the iterator, and the rest can stay. Okay, so this this kind of works if we actually add something, and we do add something, right? If we add a null, we always add something. I think it's the whole locking stuff already works, except for the waiting. We have to wait. We must wait here. But if a null handle is added, that then automatically blocks all the other factory pipeline factories, and the handle will always be overridden by the one that wrote it here. Pretty sure this works. Yeah. Okay, I'll add this a comment for this. So the first, okay, let's assume a given set index requires 4 shader resources Rx since shader resources per set index is sorted, and by canonical pointer, well, better be a canonical, but assuming that all pipeline factories will process the shader resources in the same order. Let's say R1, R2, R3, and finally R4. Okay, so the function shader resource lock set layout binding returns true. No. Attempts to add what is that? Set layout binding, of course. Attempts to add a set layout binding with the yeah, canonical set layout pointer and binding. As it would add that's not really just it. That correspond to required descriptor set. If that already exists, it returns false. If it already exists, no. If it doesn't exist, it adds it with a VK null handle for the descriptor set. this signifies that creation of this descriptor set is in progress. Okay. If it already exists, but still has a null handle. Then it returns true, but in progress. This is going to be a long comment, but well, I worked days and days on it, so it's probably worth it to document it. So hence the state of the first shader resource R1 is either 1, the key it does not exist, 2, do not have to repeat it. The key exists, but has a VK null handle. 3, the key exists with a descriptor set handle. And the pipeline factory and then should do the following. Add the key with a VK null handle and continue. No. Yeah. Continue with the next. Let's say mark this descriptor set as in need of creation and continue with the next set index. 2. Continue with R2. Yeah, continue with the next shader resource. Until it finds a case 1. Three. Back off until the VK null handle disappears. Not disappears. Is overridden with a descriptor set handle. At which point it should continue as in 2. Yep, new Vim. One, two, three, four. Mm-hmm. I don't know. Suddenly it feels like a simplification. That is it not possible that another thread for another thing at 0, 0 here for another descriptor set? It would be the same. That is possible. That is possible. And what would happen then? Nothing. I would just override it. Yeah, but that's not good. Jesus. Don't make it even more complex, please. Yeah, it is fucking possible. No, it's not. No, it is not possible. Whew. The only way that R3 could be overridden is when R3 is the first one. So if R1 and R2 do not exist. In which case the layout is different. So we would not have the same canonical set layout pointer. So that's orthogonal. Yeah, really need to get really need to have the same. Well, no, wait. I can have different resources. So we can have the same layout but different resources. Okay, but then still those other resources. Well, R3 could be the first one. Oh. Yeah, if R1 and R3 are the same type, say uniform buffer, then it's possible that another shader resource is another descriptor set is necessary for R3. R2, R5, R6, for example. That say they're all uniform buffers, whatever. So it's really, the layout is just the same. But because these are different shader resources, we need a new descriptor set. So it is simple. We only have yeah, that would still, no, it's still not. Thank God, not possible, because no, wait a minute, that's not true. They have binding numbers. The binding number must fit as well. But okay, the R1, R2, R3 are in the order of the shader resource pointers, which is super random. The binding numbers can be, anything. So let me add the binding number between brackets. Now below it, above it. Let's add a binding number. So this thing has, for example, binding number 1, 2, 1, 2, 3. And now this one must have the same binding number. So this could be binding number 2. And this is say binding number 1 still, and then this is binding number 0 and binding number 3. I mean, why not? Totally possible. Or if I want to say the 1, 2, 3, 4 are really the order in which the pointers are, right? So let's keep this in that order. Then this must be this cannot be like this. 3 comes after 2, so that's not possible. But this could be anything larger than 3 then. So it could be 4, 5, 6. And the binding number is really arbitrary. It's pretty much arbitrary, isn't it? No, I'm not convinced that this is arbitrary, because I think I made it non-arbitrary really for when they are the same layout. But okay, R5 and R6 could be textures, say. So we have, say, uniform buffer, texture. And there's a uniform buffer. And then the binding numbers can be different because it's a different layout. And then this binding number could be the same as that binding number, which means that at the moment I'm trying to add this one, I would add a null handle. And that would then also appear here. Nothing we can do about that. Or not. No, because it depends on the layout, and I just changed the layout. I changed the layout because I made these textures. I cannot make them textures, otherwise we have a different canonical layout. So they're all uniform buffers. If they're all uniform buffers, they are one and the same layout. And I think that demands that the binding numbers are also the same. Per type, but not necessarily. Right. No. Maybe I should enforce the binding numbers, which are now arbitrary, to be also in the same order as the base pointers. I mean, like I literally said, the binding numbers can be anything. Yeah, it's not good, because then we can have this. And then I could add another null pointer here, intending to lock this combination. Yeah, inadvertently also locking this. Would that even matter? Well, it seems that it doesn't matter for this one, because it just everyone is locked on R1, and R1 is unlocked once we get here. But it could be a problem that this 0, 0 is overwritten here. Actually, so it's like that, and then it's overwritten here. Which is obviously not the intention. We would be overriding a null handle that does not belong to us. I can hardly imagine that this is correct. Why not? Handle it different binding. Is it possible? Is this possible? R3. Damn it, why is it bedtime? I didn't finish this. I wanted to play Risk as well, but it's getting too late now. What? And no. Delete. And print it here. Okay, let's forget about this for the moment. And then I said that a little minus means that there's nothing, so let's fill that in. Yeah, there's still a problem left. But let's have a look at this. If this returns true, then we have to back off, right? So that's 0.3 back off until the null handle is overridden. So we kind of have to register for you have to register for an event. Surely I already implemented that, but my memory is failing me and I don't know if and how and where. Something with an event here, and then we just do return. But I must be clear about the fact that we are waiting now. Something with, so this is not returning anything yet. Yeah, it must be. It's returning true as it finishes, so it's going to have to return false, I guess. And here we have a fix me at event. So many comments. Okay, so if we just return false here, we return false, then we're going to wait for create shader resources. That's not correct. But I'm going to leave the pipeline factory here. So we must already have called wait, which means that we must pass this anyway. Not even sure that's going to be possible, because then we are no longer. Can I add a? Yeah, I'll first have to figure out how the how this event stuff works. Okay, so oh, I don't even get there anymore, but I can move it up. No, just simply print in progress. Well, retarded Squidward, I'm not calling you names. Vulkan is a successor of OpenGL, and my Vulkan engine is about taking work out of the hands of the user of the engine. The user being someone, for example, who wants to write a game. So Vulkan is very verbose, and you have to write a lot of code to get even a triangle on the screen. And the idea of using a Vulkan engine is then that becomes a lot simpler. And I'm taking that last thing to the extreme. At least that's the intention, but I only scratched the surface of Vulkan yet, I feel. So there's no end in sight, I'm afraid. We're just having fun, fun in the moment. And the moment being working on, yeah, bleh. Don't ask me. Okay, so what are we doing here? Existed, yeah, well, no, I edited it, so it should compile now. And then, yep, I'm on Arch. Let me think. I was going to figure out how these events thing stuff works. So that is a AI stateful task thing. We want to register a task for a certain event. My God, why can I not remember if I even have it? I should have it. I really should have this. But I cannot remember any keyword to search for. I could search for event, I guess. tasks are waiting for events. Well, that didn't work. There's an event type, input event. Yeah. Nah. Not convinced. Here we have something, task event. Don't you think that is it? That could be it. Let's grab that. TPS task event. Task event, task event, task event. There's a task event with documentation. Usage task A has a public member of type task event and calls trigger on it when the event occurs. For example, task event and foo available. Foo get foo only calls this when foo is available. Or sorry, only call this when foo is available. Other tasks have a state that does case wait for foo. Task A foo available register task this foo available condition. Set state foo available. Wait for foo available condition. Break case foo available, foo is foo get foo. Do I understand this? So this task executes the state wait for foo, which ends with saying that it's going to wait for the signal foo available condition and then return to the thread pool. And that is being signaled here. I mean, after it gets that signal, it's going to run again and will in the state that it's set here. So we do a break here and then we say continue here after we get this signal and then we continue there. So it goes like leave the function and then return when the signal is received. The signal is received when the event happens, I guess. So task A has a task event which sends this signal to our task when it called trigger. I think that's what I need. Yeah, there's definitely possible that multiple tasks are waiting on the same event. The event is simply that we override a certain null handle. Yeah, okay, right, no, yes. I think so. Pretty sure this is it. I just cannot remember it. So I'm gonna have to keep it on my screen somehow. And then implement stuff. Okay. Well, where do we overwrite this null handle? I think that was in pipeline factory, or no? It is in. I think it is in. I don't know where it is. Where do we do that? Go here, then I can find it back. Lock. set layout binding. No, lock set layout binding. That's writing it. So I can go there, and then we find probably very close nearby. The add set layout binding is doing it. This is shader resource. Yes, base. So the add has two possibilities. Either it finds it or it doesn't find it. If it doesn't find it, then we just insert it. That's not overriding anything. But if you found it, then obviously the handle is null, right? That's the only possibility. So either handle is null. We are here because we override a VK null handle that was added by so the handle is not set and we override it. Now we have overridden it, we can call trigger on something. Apparently my mouse is dirty enough to not work anymore. It worked. We have to call trigger on the task event. Okay, so we must add task event to base, I guess. Not really. Why not of the thing itself? The thing that has the null. So that is what iter is pointing to. We could do iter trigger, but then we do not call trigger. We said we say overrode null handle. Yes, so just try to compile it and you will automatically see what we have to add, being overrode null handle to set layout binding. It's telling us we have to add it to set layout binding. Yeah, of course. Could have known that. I don't know where that is defined. Set layout binding. Oh, I could have known that. It is defined in descriptor. Set layout binding. .h. Set handle, and then after that we call overrode null handle, which then in turn calls my trigger on null handle overridden. Which we add to this object here as a task event. No. Task event, which is a member of now I'm lost here. Stateful task. What else? Definitely going to need a header for it. The header is very surprisingly stateful task, task event. Well, and then before anyone calls overrode null handle, we want to also have the option to register. Register with, well, it is a for, register event, register null handle event. Null handle overwritten. Okay. So that's an event and we register it. I have to go back to the well, I can just jump to it from here. How does this work? You have to call register task. Okay. The register task is probably not const. It's totally const. God knows why. Call task signal condition if trigger was already called, otherwise keep task lab kit signal and call signal when trigger is called. Not really const because it alters an M register task and M NMR, but this way is more convenient. Now we can call M other task some event register task. This is my condition for my task where M other task is a pointer to otherwise const. Well, okay. Who cares about constants, right? Just fuck with it. But I don't feel like adding const here, really. Not really. Not until I need it. And then this task is going to be a pipeline factory. God knows how we get that there. Let's see if I have a pipeline factory that lights up. Yes, it does. Well, maybe it's a task. That's what it is, a task. Let's call it pipeline factory for now. It's probably in namespace task, good. So I'm going to have a task pipeline factory pointer, what I will call task. Oh wait, I should add that here. I'm going to pass the pipeline factory task, and yeah, let's not call it task then, let's call it pipeline factory. And the condition is, well, something related to pipeline factory task. Well, let's call that null handle overridden. Does this look correct? Register null handle overridden event with for a pipeline factory, which then calls register task with that event, and if I add a wait, I can rename this to something better, because I want to add a wait. I think, can I add a wait here directly on this? Probably not. I don't think wait is public. Wait, that's always the problem. There's a protected, it's not a good sign. No, it's just, of course, wait is protected. Public, what is producer access? Something else. Wait, thread pool, condition variable, AI thread safe, view text, gate, same of words, pin, same of words, starting gate. Private threading. Did I skip over it or what? So this should be one. Oh, it's just bringing me to the definition. I have to go here and then find wait. Here's my wait, and of course it is going to be protected. Yeah, well, totally. It kind of sucks because I'm totally also inside the multiplex implementation of this factory. But I guess you cannot wait here. Can I add a pipeline factory header here? Probably, hopefully. So many inline stuff. I'm lazy. It's pretty ridiculous, I think, to include the whole pipeline factory here in set layout binding. Nah, it should not do that. Should not do that. I don't like it. It's also not really necessary, of course. Well, let's try it. Because I should just go to bed, really. I'm going to bed, I think. We made a begin. It's good enough. Yeah, that my voice is soothing. I think that must be the reason that I have so many people that subscribe to my stream. Because I don't know. I cannot think of another reason. Cannot have anything to do with C++. Right? So many errors here. No member name, null handle overridden in. Oh, yes, that's true. Do I have to add that to pipeline factory? Too many errors. I want to go to bed right now. I'll fix these errors tomorrow. So, loads of viewers still, I think. 26 is a lot, in my opinion. It's always interesting to see how the number of views go. They go up and then they stay more or less the same and then they start to decline. Yes, I'm Dutch. It might have to do with the fact that a lot of people are from a certain area and then they go to bed. I don't know. I should also have a look at Discord, of course. Totally ignoring this. Okay. Oh, this is epic. I have to show that. Don't do that. Don't do that. No. Well, I don't know. This guy says, finally, I finally found my father. Thanks, Carlhood. Really funny. Yeah, Spooky Cookies said something really truthful, but I don't have a webcam, so that's not going to work. He was not talking about me, I think. There was a chat going before that. Right, okay.